Alright, welcome to this video about understanding limits. Let's start with problem 1. The directions say use the graph provided to determine the left limit represented by the little negative sign. So we can see that over here on this problem. This guy right here is this one, this limit of f of x as x approaches 2 from the left. It's got that little negative sign. The right limit, so the positive sign. The two-sided limit, or also known simply as the limit, and that's when it doesn't have a negative or a positive. And then finally, we're going to evaluate our function f at some value c. So in problem 1, it looks like we're evaluating function f at a value of 2. All right, so let's take a look at the left-hand limit. That's this guy right here. So when we're looking at left-hand limits, that means we want to find out what is our, f of x right here represents the y value, okay? So what is our y value getting closer to as x gets closer to 2 from the left side? So the left side means as if we were coming from negative infinity, okay? So as we approach from negative infinity, that's not the answer to f of 2, by the way. Let me just clear that up. Make sure that we know that that's not the answer that we're looking for that one. Let me scoot that over just a little bit. So from negative infinity here, as we approach from the left, okay, towards 2, what is our y value getting closer to? So for example, let's say I say our x value is about 0, okay? So our y value then is going to be somewhere down here, right? And then let's see, what if our x value is just a little bit further this way? Then our y value is going to be, about 0.6-ish. What if our x value is 1? Then, so here's 1, and then our y value is going to be 1. 1.5, our y value is going to be pretty close to 2, right? See how that works? And what happens if we get 1.999999999? We're going to get pretty darn close to 2. As we even get closer than that, as we get closer and closer and closer to 2, our y value here is getting closer and closer to a y value of 2 from the left. Okay? We can do the same thing from the right. So this time we're going from the positive side, so it would be like from positive infinity. And same thing, if I'm working this direction on my x value, if I plug in an x, let's say 3.5-ish, okay, the y value right there is going to be, over there to negative 0.5-ish or something like that. If I plug in 3, okay, our y value is going to be 1. Plug in 2.5. And our y value is going to be about 1.5, 1.6-ish. If I plug in 2.0000001, so just barely to the right of that 2, my y value is going to be really darn awfully close to 2. And if I get even closer and closer to 2, my y value is going to get closer and closer and closer to a y value of 2. So the limit as x approaches 2 from the right is also 2. All right, so that's from the left and the right. If I want to actually evaluate the limit to find out if it exists or not, what needs to happen is the left limit and the right limit have to be going to the same place. So in this case, the left limit is going to 2, the right limit is going to 2. Those two things are the same. So the two-sided limit from the left and the right are going to the same value. And so our answer here is also going to be 2. All right, so there's the limit as x approaches limit of f of x as x approaches 2 from the left, right, and from both sides. All right, finally, let's look at what happens when we plug 2 into our function f. So here, I want to take 2. So we're looking at an x value of 2. What happens when I actually plug this value in? Well, let's see. If I plug it in, I come up here. I'm going to go right past this spot because that's a hole. There's not, the function is not defined at this point right here. It's like a little gap in our little parabola right here. So I'm going to go right through until I find the graph. Oh, there it is right there. There's the graph right there, and that's a y value of 3. So the limit exists. It's equal to 2, but the actual value at 2 is equal to 3. And that does it for problem number 1. All right, problem number 2. We're looking at this time g of x. So what is the limit of g of x as x approaches 1 from the left, from the right, from both sides, and what is g evaluated at 1? So let's go from the left. So as we approach 1 this time from the left, so that's going to be from negative infinity. So we come along this way. It looks like our our y value is going down as our x is going towards 1, right? So our y value is going down as we get closer and closer to 1. Our y value, in fact, is getting closer and closer to -1. And you can see that if we plugged in, like, say, this x value, if I found out what the y value was, boom, right there. So I'm at 0.5 right there. If I plug in 0, it looks like I even get out 0. If I plug in positive 0.5, I get out negative 0.5. If I plug in something really close to 1, I'm going to get something really close to -1. Even closer to 1, I get something even closer to -1. And the closer and closer I get to that 1, the closer my y value is going to get to that -1. All right, from the right-hand side, similar. We're going to start from over here from positive infinity as we work our way from the left. Okay, so from the positive direction, what happens as we get to 1? Well, notice I'm not going to be following this part of the graph. I'm going to be following this part of the graph because as x is over here, like if I plug in 2, for example, if I come up here, ding, there we hit it right there, and that's equal to a y value of 2. And then I come in a little bit closer to 1. And I come up with a value a little bit smaller than 2, getting closer to 1 this time. Closer here. And you can kind of start and see what's going to happen here. As we get closer to 1, my y value is getting closer to 1, positive 1. All right, so now we take a look at what is the two-sided limit of g of x as x approaches 1. So in order for the limit to exist, the left-handed limit and the right-handed limit have to be going to the same value. In this case, they are not. The left side is going to a place completely different than the right side. So this limit does not exist. They have to be going to the same value for the limit, the two-sided limit, to exist. All right, and then finally, let's take a look at what happens when we evaluate g at 1. So here is 1 right here. So we're going to see where our graph is. Down here is a hole, so we're not going to go that way. Up here, though, there's a solid dot, so that is going to be our value. So I plug in g of 1, and I get out 1. All right, let's come down here and take a look at question number 3. What is the limit of h of x as x approaches -2 from the left? So here is -2 right here. It looks like we have on the left side here, we've got a little asymptote. So that dotted line right here is an asymptote. That graph's going up to it. From the right-hand side, it's not an asymptote, just a linear function. All right, so let's take a look. -2 from the left. So that's, once again, that's over here from -infinity as I work my way towards -2. It looks like my y value is going to be going up, 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 forever and ever and ever. If you remember what we talked about with asymptotes, that means that this graph is going to get continuously closer and closer and closer to this asymptote the closer we get to that x value, but it will never, ever, ever, ever quite get there. So what's happening here is our y value is increasing without bound. It means it's just going to go up and up and up forever the closer and closer we get to -2. So you could say that this limit does not exist because it's not getting closer to a specific number. However, for this class, we are going to, for one-sided limits, we are going to identify which direction it is going. So for this one-sided limit right here, our y value is getting closer and closer and closer and closer to positive infinity. All right, it just keeps, it increases without bound is what that means. From the right-hand side, so this little guy right here, we are looking at as we approach it from positive infinity. So as we come this way, so I'm going to trace our little line right here. So as x moves, as I move this cursor further and further to the left as I follow my graph, what is my y value getting closer to? Well, it's going to stop down here. It's going to get closer and closer to -1. And then finally, what is our two-sided limit? So for the two-sided limit to exist, the left-sided limit and the right-sided limit have to be approaching the same value. Okay, in this case, this one is not approaching, from the left is not approaching any value. It's just increasing without bound. And from the right, it's approaching -1. So this one also does not exist. I say also because that was the answer to number 2. And then finally, let's take a look at the evaluating function h at -2. So I plug in -2. There's nothing up here, nothing down here. There's a solid dot right there. So we plug in -2 and we get out 0. All right, question number 4. we've got function f of t this time, and we'll see that a lot in this class where we've seen 3 problems now where they have different names, f, g, and h. This time I have a different input, and that's just fine. And it's not a big deal. So that the value inside here is going to be our independent variable. So that's going to be our horizontal axis, and then our f, or f of t, is going to be our vertical axis. So here we go. We are looking for the limit as t, this time, approaches 0 from the left of f of t. So from the left, that's from negative infinity. So as we start from this side and work our way towards 0, we're just going to trace it here. As I keep continuing to the right, closer and closer I get to 0, my y value just kind of stays the same at negative 1. So our y value is going to get closer and closer to negative 1. Or our limit, I should say, becomes, our limit is negative 1. Even though the value always is negative 1, we're still going to say the limit itself is negative 1, because that's what, basically what you're thinking of is if you had to guess what this function would equal if you couldn't see. Let me just cover this up. Just pretend that we had no idea what this value was. Okay, whether it was a solid dot, a hollow dot, or anything like that. If you had to guess what would happen when you plug in 0 into this function, what would you guess? You would guess negative 1, right? If you were using this part of the graph. Okay. Now, if I was using the other part of the graph from the right, I'm going to cover this up. Imagine we had no idea what was right here. Okay. If I use this part of the graph from the right, what will we guess is our answer when we plug in 0? We would guess that our answer is positive 1. And that's kind of another way to look at limits. Okay. So now let's see. I guess I got to erase those 2 things though, because we're gonna need them in just a second. Whoops. Didn't mean to erase everything there. All right. Well, I know what happened. I deleted my other layer, so we'll just do that. There we go. So this is positive 1. All right, the limit as t approaches 0, the actual limit, so the 2-sided limit, remember that means the left and the right have to be approaching the same thing, which in this case they are not. So our limit does not exist. And then we want to see what happens when we plug 0 into our function f. So I go over here to 0, I try plugging it in, but if I come up from top, I just go right past that dot because that's a hole. There is nothing up here. There is nothing down here. Our function right here is actually undefined at 0. There is no defined value, defined y value associated with 0. So this guy is undefined. 0 is undefined for this function. There is no output for the input 0. All right, scroll down here, take a look at number 5. This time we're dealing with function g of a. So our input is a, our function is g. So here we go. We want to find out what happens the limit as a approaches 2 from the left. So here's 2 right here. All right, so as we come in from the left, we're kind of bouncing all over the place. So our y value is increasing, it's increasing, and then it kind of peaks out. And now it's decreasing, decreasing, decreasing. What is our y value getting closer and closer to as our x value gets closer and closer to 2? Well, it looks like it's going to get closer and closer to 0. All right, from the right, so from the right, the positive side, same thing. We're going to kind of follow this guy around as we get closer and closer and closer to 2. Our y value is going to get closer and closer and closer and closer to a y value of 0. Our 2-sided limit, or the actual limit, if you will, of g of a as a approaches 2, the left side and the right side have to be approaching the same thing, which in this case they are. They are both approaching 0, so the limit is going to be 0. And then finally, what happens when we evaluate g of 2? We plug 2 into our function, so we see what our plug in 2, and our output is 0. So the answer to this one is all zeros. All right, problem number 6. We are looking at h of s this time, so function h of s. So s is our horizontal axis, h of s is our vertical axis. So what happens when we approach 1? Here's 1 from the left. So we come in this direction. So we get closer and closer as this cursor moves closer and closer to an x value of 1. What is our y value moving closer to? Looks like we have an asymptote up here. And so that means that our equation is going to go up and up and up without bound. The closer and closer we get to 1, this guy is just going to get closer and closer and closer to this asymptote, but never ever quite get there. So he's just increasing without bound. So technically this limit does not exist. but since it's a one-sided limit, we do want to identify which direction it is heading, and in this case it is heading to positive infinity. All right, one-sided limit again from the right. This time, as we follow this guy from the right, closer and closer to an x value of 1, our y value is going to go down, 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 and once again we have that asymptote. So it's going to go down, 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 and get closer and closer and closer to this, as we move closer and closer to 1, and this is going to decrease without bounds. So just getting closer to negative infinity. And finally, our two-sided limit are the left and the right going to the same place, same value, I should say, and they are not approaching any value. This one is increasing without bound, and this one is decreasing without bound. So not getting closer to a specific number. Infinity is a destination, not a number. So the answer here is does not exist. And we'll see on another one later on, even if this had been a positive infinity, if these had both been positive infinities, the answer for the two-sided limit would still be that the limit does not exist because the left and the right are not approaching the same value, the same number. Okay, think of infinity and negative infinity, or in this example I'm coming up with right now, two infinities, as directions, not an actual destination, not an actual value. Okay, so these are directions they are heading. They're not getting closer to a specific value. They're just increasing without bound, and so the limit is not getting closer to a specific value. And so the answer would still be does not exist. And we'll see that on another problem. I just thought I'd bring it up. All right, and then finally, when we plug in 1 into h, you'll notice there is nothing up here and nothing down here. It doesn't look like our function is defined at 1, so we're going to put undefined. All right, let's come down here and do problem number 7. It says directions. Use the graph of the function f to decide whether the value of the given quantity exists. If it does, find it. If it does not, explain why it does not exist. All right, so it's kind of the same thing as the last one. Just got a couple more questions to answer. And so here we go. Let's do light blue. All right, f of 1. So we come over here. This is our function f. If I plug in 1, I get out 2, looks like. That's easy peasy. In fact, let's just do all the value ones. Let's jump down here to f of 5. If I plug in 5, what do we get out? Nothing. There's nothing there. Remember, this is a hole, so we skip right over it. There's nothing there. F of 5 is undefined. It's not defined. Our function is not defined at 5. There's no output for the input 5. All right, then f of 0. So let's go find 0. Here's 0 right there. And so as we come up, ding, there is the graph right there, and it is at a y value. It looks like 3. So f of 0 is 3. All right, so now let's do the limits. So let's see this one right here. Limit as x approaches 5. Notice that it doesn't have the negative or the positive sign. So this is the two-sided limit. So really what we're going to look at is the left side and the right side and see if they're going to the same place. So as we come up here to 5, so here's 5 right here. As we follow our graph from the left, get closer to this x value of 5, our y value is getting closer and closer and closer to 3, it looks like. Okay, so from the left it's equal to 3. From the right, we're going to do the same thing, get closer and closer to 3. So the left and the right are both approaching the same value, and therefore the limit as x approaches 5 is 3. All right, let's take a look at x approaches 1 from the left. So here's 1. As x approaches 1 from the left, so we're coming in from the left side, from the negative infinity direction. So we're going to follow this guy around. Our y value is just past 4. Now it's like at 3.5. Now it's at 3. And now we're kind of coming back up towards 4. And getting closer and closer and closer to a y value of 4, the closer and closer we get to that x value of 1. So this is going to be 4. From the right, so let's start from way over here. So we're at a y value of about 2.5-ish, and we're getting closer to 3. And we hit 3 somewhere in, well, we don't quite hit it because of the hole, but we got pretty darn close to 3. Now we're coming back down. Now we're about 2.5, 2, getting closer and closer and closer to our x value of 1. And if you notice our y value, it is also getting closer to a y value of 1. All right, so as we look at these, we don't have to answer this question, but let's take a look. The limit at x equals 1, the actual two-sided limit, is not going to exist because from the left it's equal to 4 and from the right it is equal to 1. So our limit's not going to exist. And that does it for problem number 7. All right, problem number 8. So here we have this fun little graph. Let's take a look at our f of 4 here. So we plug in 4 and we get out, it looks like, come down here, we get out a value of -2. Plug in 2 and we don't get out anything. There's a hole right there and it's not defined anywhere else. So this is going to be undefined. And plug in 6. Plug in 6. Up here it's undefined, but down here we get a y value of -2. Alright, that takes care of those ones. Sorry, I have people coming in and out of my door. That's why the door keeps slamming. And let's see, so now let's take a look at the limits. So as x approaches 5, once again we are missing the negative and the positive sign. So we're looking for, this is a two-sided limit. So the left side and the right side need to be approaching the same thing. So as we come in from the left, so here's 5 right here. I just kind of drew on that. So here's 5 right here. As we approach it from the left, it looks like our y value is going up and up and up and up and up. It is increasing forever without bound. It is just going to keep going. It's not approaching any specific value. It's just going in that direction. So from the left, it's going to positive infinity. In fact, I'm going to write positive infinity up here so we don't forget. From the right, notice if I come up here, blah, 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 and then I skip down here because I'm getting closer to 5, right? So I'm going to come back down here. I don't know what's happening as we get closer and closer to 5. So we come here, and it is also going up and up and up and up and up without bound. So the left limit and the right limit are both going to positive infinity, but remember, we're going to treat this as a direction, not a specific value. And so the limit as x approaches 5, it is not approaching a specific value of y. It's just going up and up and up forever. And so this one is not going to exist. Does not exist. I'm just going to abbreviate it. DNE. Does not exist. All right, let's take a look at the limit as x approaches 1 from the left. So here's 1. From the left, as I follow this guy down, he's going to go down, 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 closer and closer and closer to that asymptote, the one we're trying to get to. But he's going to go down forever and ever and not approach a specific value, but just keep going down, which means he is approaching or going in the direction of negative infinity. Okay, so it's not a value, it's just kind of think of it as more as a direction. And finally, x equals 2. So here's x equals 2 right here. From the left, so we follow this guy down, it looks like from the left we're getting closer and closer to a y value of 0. And from the right, we're coming up the other direction, but also getting closer to a y value of 0. And since the left and the right are both approaching the same value, the actual limit itself does exist, and it's equal to 0. All right, question number 9 and 10. This is direction. Sketch a graph of a function f that satisfies the given values. There are many correct answers. Remember, functions only have a single output for every input, or in other words, they need to pass the vertical line test. So here are 7 things that have to be true for our graph. We're just going to draw a picture of what this could look like. And since some of us can do things a little bit differently than others, there are many different ways to answer this. So what we're going to do, I'm going to put in green the things that have to be true for everybody. So let's take a look at like this first one. If we plug 1 into our function f, we have to get out 3. So everybody's graph should at 1, 3 should have a solid dot at 3. That has to be true for everybody. Okay, I'm going to put a little check mark next to that guy. Know what we've done. All right, let's do another point. If I plug in 3, we get out -2. So plug in 3, get out -2. That guy has to be on everybody's graph. Plug in -2 and get out +1. That has to be on everybody's graph. All right, and that takes care of the easy ones. Let's see what these other ones are. This is a limit. That's a limit from the left. That's a limit from the right. And this one says the limit as x of f of c, of x as x approaches c, exists for all values of c except at -2 and 3. Now so it sounds like a mouthful, but what it's saying is, hey, for all of our inputs of our function f, every single one of them, the limit has to exist, which means coming from the left, coming from the right have to be going to the same place. The only places that doesn't happen is at -2 and at 3. So basically, at this point, we can't come in and out of the same value at -2, and same thing for 3. But like at 1, I have to come in and come out of whatever value we want. It doesn't necessarily have to be 3, but we'll see what happens. All right, so here we go. limit as x approaches 1 is equal to 1. So at 1, our limit has to be 1. You notice we have it defined way up here, but our limit, as we get closer and closer to 1 from the left and closer and closer to 1 from the right, we actually have to be approaching 1. And since we already have it defined, we're going to treat that as a hollow circle, and that wasn't a very good hollow circle. Let's try that again. Make it nice and big. There we go. So I'm just going to put a little coming into that point, coming out of that point. So that's going to be our right limit and our left limit. So I know I have to come into that value right there. It's defined up here, but the limit exists down here. So that one is now true. The limit, let's do this one, -2 from the left has to equal positive infinity. So here's -2. As I come closer and closer to -2 from the left, I have to get closer to positive infinity. So he's going to do something, we're going to have an asymptote right here, and so he's going to do something like this. He's just going to get closer and closer and closer to positive infinity. That takes care of that guy. And we can fill in this other part later. 2 from the right, so positive 2 from the right equals -2. Kind of wonder if I meant to put -2 right there, but it doesn't matter. The limit is 2 approaches 2 from the right is -2. So 2 here down here is -2. So I'm just going to put a hollow dot for right now. Oh, sorry, that was a really bad hollow dot. And I'm going to be approaching -2 from the right. So I have to come into that point right there. So all this green stuff is everything everybody has to have. Now how you fill in the rest of it doesn't matter. So that's this part right here, though. It says the limit exists for everything. So basically the easiest way to make that true is just to start connecting all the dots. So here we go. I'm going to do this one in red. So I'm just going to fill in the blanks. So I need to make sure that my limit still does not exist at -2, which it's not going to because one side is is increasing without bounds. So that's not a problem. I'm just going to kind of swing him around like that. That looks good. I also have to have the limit not exist here at 3. It does need to exist at 2, right? Because it says it doesn't exist at -2 and 3, so it does need to exist at 2. So I need to actually come out of that point right there too. So we'll do something like that. And then connect those 2 dots. But we know 3, it's not supposed to exist. So if I come into the point at this side, which is just fine, I need to come out someplace else. I cannot come out right here or else the limit will exist. So let's come someplace up here. Let's put a little hole right there. We'll come out of that hole and do something like that. And then let's connect these dots. Let's just go them straight across. Just make it easy. And there we go. Now the limit exists everywhere. Like if I want to find the limit at 4, right? I come in and come out at the same point. Okay, that exists. So the limit exists everywhere except for at -2 and +3. It still exists at 1 and it still exists at 2. Okay, it doesn't say anything about being defined everywhere, so I don't need to worry about filling in a dot for here, or because right now it's not defined. It's defined everywhere else, it's just not defined at 2. So, but that's not a problem. It doesn't say I need to do that. So there we go. Now defined for everything. There's problem number 9. All right, this is problem number 10. Once again, we've got 7 different things that need to be true about our graph down here. So let's start with the easy ones. Let's do the points. So if I plug in 0, I have to get out 0. So I know that that has to be a point on my graph. If I plug in -2, I have to get out 2. So if I plug in -2, I have to get out 2. That has to be a point on my graph. So both of those, check. Let's see, these are all limits. We'll look at those in a second. This one says that f of c is defined for all c values except c equals 2. That means our function is going to be defined everywhere except at c equals 2. So looking back here on number 9, I actually did that with number 9 on accident. My function is defined everywhere except at 2. If you notice here, I've got a hole right here and there's nothing defining anywhere else. Like at 1, I've got a hole as well, but it's been defined up here. Same thing at 3, kind of the same thing at -2. So we have to make sure it's defined. Every x value has an output with the exception of 2. That's what this guy means. We'll come and do him last. So the limit as x approaches 0 from the left has to equal 1. So as I come at 0 from the left, I need to get closer and closer to 1. So I'm going to put a little hole up here and have a little arrow coming out of there, kind of a little line. So I know I have to come into that point right there. So he's done. From the right, I have to get to -1. So from the right, so put a little hole down here, I need to come into -1. Check. From 2, I need to come into -1. So from both sides, the limit exists. So I can put a hole right there, and from both sides like that, left and right. Okay. So I'm putting a hole because I'm not sure if I want it defined or not. I could put a solid dot, and that would still make this true. But keeping in mind this guy down here, I don't want it defined at 2, so I don't want to worry about that. So he is done. At -2, we want it equal to 1, and it's left and right limit, so it's a double-sided limit. So at -2, we want it to equal +1. I already have it defined, so this one has to be a hole. And I want it to come in and out of that point right there. And that takes care of everything that needs to be true. Now we just have to fill in the gaps because I need to have it defined everywhere. Like at -4, it needs to be defined someplace, which it's not right now. So let's just come over here. And so the red part's where you can kind of play with it. You can do whatever you want. You can do a little squiggly line if you want. But we'll do something like that. So it comes into that point right there. And we'll just do an easy one, connect those two dots right there. And we'll connect those two dots right there. And then we'll just go whoo, off to the side like that. And now I think we are defined everywhere. We're defined here at -2. We're defined at 0. We're defined at all the places where I put that red line. The only place I'm not defined at is 2. So this guy is also now correct.